In this video, I'm going to show how the nitrous control works. First, you'll go to Extended, go down to Nitrous System. Right now it's turned on. Initially it should be turned to off. We'll turn it on. And basically the first one is turn nitrous on above what RPM. So this is basically where you set your window. You turn it on at whatever RPM, and your max RPM is here. Coolant temperature above, you can have it only active above a certain coolant temperature. I just got it set to 0 in this map here, but you can have it set to whatever you want. TPS, you can have a minimum throttle position angle, so it won't activate under a certain throttle angle. Input location, leave it to local. Enable input. This is the generic nitrous input on there, but there's two others that you can use. If you're not using launch control, you could use PEO. The shifter input is usually PE1. If for some reason you wasn't using the air shifter, you could use that. But the generic one that I use is S5. Output location, just leave the local. Just leave the output pins to this one here. It's actually only on one output for the single stage. The single stage nitrous output is just strictly on and off. There's no progressive to it. So basically, when it gets 3,000 RPM and that button is activated, it turns the output on. Another thing I added for the nitrous system was the ability to tune a small dry shot. So like if you had a 50 shot dry shot, it's progressive, but you can tune the fuel side of it by going here to Fuel VE Table 3. And basically what you could do is you could take your standard VE table and just export it and save it. Just name it whatever, save it. You go here to Fuel VE Table 3 and click on it and open table whatever you named it to. And now got is your standard VE table 1, your standard table here, and you can tune off of this. So say you had your standard table here and you wanted to just bump it up 10%, go 1.1%. Okay, so what happens is whenever this input goes high on the nitrous input, is the only input, or JS5 is the only input that you can run 12 volts to as your activation input. So if you had it on, say, your high beams or something like that for the nitrous input activation, you could have a 12 volts for the input on it, will activate that input. All others require ground input. If you put 12 volts to those inputs, you will fry them. So be sure to remember that only the nitrous on the box can have 12 volt input to it. But anyway, when you hit the nitrous input, you'll see the N20 comes on, and it'll actually switch from the main fuel table here. It'll switch VE1 and actually use VE table 3 for the fueling. So instantaneously, you'll get a 10% raise in your fuel in your VE table. But you can set this whatever. So this is real good for tuning a dry shot, basically with just the fuel VE table 1. I don't actually have an ignition read for the first stage right now, but I'm going to add. But it's the initial on the first stage. Now, if you want a dual stage, the second stage is actually progressive. So you can have the first stage is simply on and off, and the second stage progressive. Or you can just have a single stage progressive and just forget about the first stage at all. You still have to have it turned on, but you do not have nothing hooked to that output at all. And not worry about it, just because if you're going to use the second stage only, not the first stage, just import your Fuel VE Table 1 to Fuel VE Table, and it would seem you would notice that it switches, because basically it'll be using the same table. It's all at the same time anyway. So if you want a full progressive single stage, just set that and export your VE Table 3. It'll basically ignore that, and you'll have your second stage be active. Now, to activate the second stage, we'll go to Advanced, and this was trick actually uses the boost control output as the nitrous output. But all we do is we go here and we turn it on, and we hit burn, and that's it. And that's all we do in the boost control menu to be able to activate the second stage. Once you turn that on, the nitrous second stage window will open up. We click on, and now we can go here and set our solenoid frequency. from anywhere from 78 all the way down to 11.1 hertz. Most of them I think are around about 26 hertz on both solenoids. Once you got that set it to whatever your point is. You can set which gear it's activated in. And you do have to have your gear position sensor activated for this to work correctly. There's a way around. We can fudge around it if you don't have, but for the way it's intended is it's intended to be gear activated. And basically what it is anything above whatever gears in this window, it will be activated. Anything below that, it won't. So 1, 2, 3, and 4, it won't be activated in. Gears 5 and 6, it will be activated in. And you can scroll down to whatever gear you want. It has to be a minimum of gear 2. Because basically you wouldn't need it in first gear to be activated. I may change that where there's no gear at all, or you can select between gear or no gear. But right now it's just coded to where it has to be in second gear or above to work. The output pin, you can select between 3 output pins, IC 1, 2, and 3, and I have them in the wiring diagram of which ones you can pick. Nitrous regain, what this is off. Basically, it will start over if it comes out of the loop, like if you loft the button and come back into it, it'll start over, or you can hit on and it'll stay at the point it was when the button was released. It'll come right back into the table. That's probably what we want to use is that way. Set that to 0 for delay. What this is delay after the first stage. So when the first stage is activated and it goes into gear, it delays for that many seconds after the first stage. You can just leave it at 0 unless you need a big delay between the two. Minimum RPM is the first button or the first window, and the maximum is the second window. So this is your window switch for the second stage, meaning it's activated between these two. For a bike, of course, it's going to be way above that. So we'll just put like 12,000 RPM for that. Now it has to be in gear. Right now it's at 0. Let me set the to coolant, and now I can select through my gears. We'll just leave it at that. When I push the button, let me turn power cycle it so that everything is all of our settings have taken. When I hit the button, and we'll change this right here. We'll go down to 2500. I hit the button. See the first stage and the second stage come in, and you'll see the ignition advance is starting to retard progressively. Those tables are here. We've got a progressive chart, which is what this is. This is the duty cycle for the nitrous solenoid. Expand this table out here. This window and get it out of your way. If you want to see just the table, you can do it manually here too. This is seconds, 0 to 10 seconds basically. And your duty cycle, 0 to 100% duty cycle. You can drag them by hand if you want. You can just click on the dot and drag it down. It's a pretty good sized table, so you got plenty of adjustment for curves or however you want the whatever you want the duty versus time to be. One thing about this, because there's not enough room on the chip, there wasn't enough room to have separate times for each table. Is that whatever you put this time to is what it'll be changed to on the pulse width table. So right here we have it 9.52. That's what our time will be on this one too. Max is at is 9.5. You'll see whenever I move this, it moves that also here. So really, if you set the time here, you can set the time. The tables will already be preset for you. They all share the same scale time, but each one has their own percentage. You can set the scale for specific things. So the duty percent for the cell has its own duty percent you can set. The amount of fuel it adds over that period of time is preset, or is not preset, is independently settable. So you can set it whatever, and this is in pulse width millisecond. So if you need 0.1 millisecond at your maximum amount of nitrous you're injecting, you just put 0.1 second. If you need 2 seconds, 3 milliseconds, whatever, you can punch it in right here. So you need 3 milliseconds of additional injector. You can set it there, or you can just grab the dot like it shows here and pull it up to whatever you need. And for the ignition retard, set for it also waxes out at on the main table is where it will end and add on this table. It's kind of it was kind of logical for me to do it that way because I wouldn't see it needing independent times for each thing when it's all going to be based off of the curve of the duty cycle of the valve anyway. So it just seemed to make more sense and save more space to just share the same time for all 3 tables, but just have the actual settings independent. But you can come in here and you can set the amount of ignition retard over time in this table here, or you can just grab the dots and retard up to 30 degrees per time. But that's pretty much how the nitrous control works. I'm sure there'll be more changes done to it over time. I would like that dual progressive set to this, but right now it's going to be single. We'll do some tests and see how it works. And if we need to do any tweaking there, we'll go from there, and then I'll progressively try to add more stuff if we can. That's pretty much it for the nitrous control. And that's pretty much it for this video.